Okay. Let's zoom out just a little bit. And we're going to start out and we're going to talk about the union and intersection of sets. Okay, the union symbol is the U here, and the intersection kind of looks like a funky N. Okay, now let's say we start out with the sets. Here, I'll put this down here so you're not confused by those. Let's start out with these sets A and B, and the first thing I want to do is the union of A and B. So A union B. Now, so what we're going to do with this is we're going to find all the things that are in both sets, okay, in other words, all together, but we're not going to duplicate any members. And I'm going to put them in number order, okay? So I'm going to start over here and do 1, 2, 3. Okay, 3's picked up over here, okay, so we won't duplicate it. 4 is here. 4's picked up over here, so we won't duplicate it. And then we have 5 and 6. So A union B has 6 elements or 6 members. Okay? Then A intersect B. And I want to look for all the things that are common, that are represented in both sets. So I'm going to circle those. Alright, there's a 3 in both. There's a 4 in both. There's not a 1 and 2 in this one. There's not a 5 and 6 in this one. So the 2 that I've circled are the intersection of A and B. Okay, things that are common. All together, common. Alright, now let's look at this one. Alright, we've got sets. A is the set 0, 2, 4, 6. B is 1, 3, 5, 7. So let's talk about A union B. Okay, so over here we got 0. Here we got 1. Here we've got 2, 3, 4, 5, 6, 7, and so forth. Now, I could have done, this one would have 8, this one would have 9. I could have put those in there. But the 3 dots are fine because that says it goes on and on and on forever in a like fashion. Now, if I wanted to write this using the set builder notation, A union B would be the set of all elements such that those members are whole numbers, because whole numbers start with 0. Okay, now let's talk about A intersect B. What's common to both of them? Well, these are even numbers and these are odd, so they're not going to have anything in common. So I could write that with a set with nothing in it. Now, it's not the set with 0 in it, because if I put a 0 in here, I'm saying that the number 0 is in both, and it's not. So it's a set without anything in it, or the empty set. Okay? In other words, the not symbol, the circle with the line through. Okay? So that represents A intersect B. Okay? Now I'm going to talk about the associative property. You know, we have the associative property is true for numbers. So if we associate numbers, we can add 3 numbers together in different order and so forth. And let's see if those properties, the associative property is true for sets. Alright, so what we're going to do is we're going to do what's in parentheses first. So what I'm going to be doing is I'm going to take A, and that would be this set. And then once I do B intersect C, so I'm going to do that first. So B intersect C. I'm going to work the left-hand side, this one right here. I'm going to call that number 1. All right, so B intersects C. So that's the things that are common to both of these. All right, so what's common to both? We have a D and an E in both of them. So B intersects C is the set DE. Now, I want to intersect that with A. All right, so that A intersect B intersect C would be the set A with this right here. So what's common in these? I have a D that's in both. Okay? Now, let's see if I get the same thing when I do this. So let's call this one over here number 2. So let's go over here. Now let's do A intersect B. Okay, so what's common to A and B? Well, let's see. We've got a C and a D in both of those. Okay, now let's do this, A intersect B, and then let's find what's common to C. Alright, so I have this, and I have C. No, I'm sorry, C. So when I look at this, I have a D that's common to both. Okay, so the top one works. Alright, let's look at the... So we're going to look at this. These two are the same, so this part worked for that one. Alright, let's look at the bottom. Alright, let's try B union C. Okay, so this is number 3. So we're going to look at the left side there. So we've got B union C, and it's in parentheses, so we're going to do it first. So B union C is all the things that are in both of these without duplicates. So we have C, D, E, F, and G. C, D, E, F, G. Alright, now I want to take that and I want to union that with A. So A union B union C. So A is up here. So we want to put A with this. So all that's going to do, we've already got C and D, so we're going to add A, B. So that would be the set A, B, C, D, E, F, G. Alright, now let's look at number 4. Okay, which is this one over here. Alright, so we're going to do A union B first. And A union B is A, B, C, D, E. Okay, then we're going to do, take that and union C. Alright, so we're going to take this one and we're going to go with C. So here, it's everything that's in both. So we've got A, B, C, D, E, F, G. And those two are the same there. Okay? Now, it's true for what we've had, but that doesn't mean it's always true. We could always look and try to find a counterexample, but it will be true for some. Now, let's look at the distributive property, and it's the same thing. So what I recommend you do right now is stop the video. Now that you know how to work each side out, stop the video and then see if you can work it out, and then we will get the answer here. Alright, so let's work it out and let's see what we get. Are these two things equal? Alright, so A we're going to use the same sets that we had just a minute ago. So I'm just going to fold that down there so we can see them. So we've got B union C. Now, I'm doing that because we've got this right here. Okay, B union C I wrote down here already as this. So if I put that with A, now notice this is union, this is intersection. So B union C is this, and then I want to find what's common to this and A. So A has this. I'm going to write these down. That might be easier. Set A is this. And then our B union C is this. So what's common to those? Then I have a C and a D that are here, and a C and a D that are here. So this would be the set CD. All right, now let's look at this one. I've got A intersect B. So let's see. A intersect B up here is the set CD. And then A intersect C. Okay, we don't have A intersect C done. So A intersect C would be what's common here. So let's see, I have A, B, C, D. So D is what's common. Now, we're going to union those. So when we union those, we have C and D. Okay? So it works then with sets to the distributive for the distributive property.